वेलकम स्टूडेंट्स, आपका YouTube चैनल शंकर कोचिंग में स्वागत है। मैं प्रोफेसर प्रेम शंकर आज 6th क्लास के स्टूडेंट्स को मैथ्स का NCERT बुक से चैप्टर नंबर 2 होल नंबर पढ़ाऊंगा। अगर मेरा ये वीडियो आपको पसंद आता है तो प्लीज लाइक कीजिए, सब्सक्राइब कीजिए और दोस्तों के साथ शेयर कीजिए। तो चलिए वीडियो स्टार्ट करते हैं। The chapter is whole numbers. We'll discuss one by one. Introduction, then number line, then properties, identity, and lastly, this is the patterns. So let's suppose we want to find a successor. Let's suppose we want to find a successor of any number. Successor of any number. Let's suppose I am taking the successor of 16. So what will the successor of 16? So it is what? You will add 1. 60 plus 1, that is equal to your 70. So this is the successor of this 16. Now let's suppose I am interested in predecessor. Let's suppose I am interested in predecessor of 17. Okay, predecessor of 17. So what is the value of predecessor of 17? So I will subtract 1. So 17 minus 1, that is your 17 minus 1, that is your 16. Okay. Now I am taking a natural number. Let's suppose I am taking the case of natural number, a natural number. Okay. Let us suppose the case of natural number 1. Okay. I am taking the case of a natural number 1. So for the 1, what is the successor for this one? Successor. I will want to find the successor of 1. So successor of 1 is 1 plus 1, that is your equal to 2. Is the successor. Now let's suppose I want the predecessor of 1. Predecessor of 1. So what is the predecessor of 1? So it is your 1 minus 1, that is equal to 0. See, in the natural number, what is in the natural number? The natural number starts from 1. 1, 2, 3, 4 like this. But if I start the natural number with 0, means 0, 1, 2, 3 like this. So this is called the whole number. This is the called as a whole number. So we will derive the whole number from natural number. Means natural number is 1, 2, 3, and if I start it from 0, 1, 2, 3, then it is called the whole number. So this is all about the introduction. Now we'll discuss the number line. In the case of the number line of a whole number, the number line will start from 0. So I will explain the number line in this way. This is in this way. It will start from 0, 0, 1, 2, 3, 4, 5, 6, and then 7, like this. So it is a number line. Now let's suppose I want to discuss addition, subtraction, and multiplication with the help of number line. I want to discuss, let's suppose I want to discuss the addition, subtraction, and multiplication. I want to discuss one is the addition, addition, another is the subtraction, and multiplication with the help of number line. Let's suppose I am taking the case of addition. I want to take the addition 3 plus 4 with the help of number line. So first of all, what I will do, I will draw the number line. Okay, I will draw the number line. First. So as you start from 0, why? Whole number is starting from 0. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, like this. I want to add 3 plus 4 with the help of number line. So first of all, I will search where is 3. So 3 is somewhere here. This is the 3. Now plus is given, positive addition is given. So we will go in the forward direction. How much I have to go? 4. So this is 1, 2, 3 and this is 4. So if I see the number line for the addition, so 3 plus 4 is equal to 7. Now come to the subtraction part. Let's suppose I want to find subtraction of, I want to find subtraction of 7 minus 5. 7 minus 5 with the help of number line. So how do I find it? So first of all, I will draw the number line. First of all, I will draw that. It's the whole number, so obviously it will start it from where? It will start it from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I want to find 7 minus 5. So first of all, I will locate this 7 first. Then this is the subtraction. So I will go not in the forward direction. I will go in the backward direction. So 7 minus 5. Okay, so backward direction I will go. So it is this is 1, 2, 3, 4 and lastly 5. So that means 7 minus 5 is equal to, this is equal to 2. So this is the case of the subtraction. Now come to the multiplication. Again for the multiplication, I will draw the number line first. First of all, I will draw the number line for the case of the multiplication. So it's a whole number line, so it will be started from where? It will start from 0. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is the number line. And I want to find how multiplication of what? I want to find 4 into 3. I have to find the 4 into 3. Okay. Means I will take this 4 interval. 1, 2, 3. So that 4 interval I will take. And then I will go how much? 4 up to 4 I will take. And then I will go to the 3 times. Okay. So 4 into 3. So this is 1, then 1, then it is 2, then 3, and lastly 4. So we are coming for the 12. So that means for the multiplication, 4 into 3 is equal to 12. So this is all about how the number line, we represent the number line, and how to make the addition, subtraction and multiplication with the help of number line. Now we will see the properties. In the properties we have the closure property, commutative property, associative property and distributive property. So see, first of all I will see the closure. I will see the closure property first. Okay, this is, I will see the closure property. Okay, closure property, and then I will see the commutative, associative and then distributive. Okay, so first of all I will see the closure property. Okay, this is, I will see the closure property. Okay, first is your, this is the closure property. Closure property. Okay, for the closure property, I will see first addition, then I will see the subtraction, addition, multiplication, subtraction and division. Okay, so I will check this closure property for addition. Addition, then I will check the for this closure property for multiplication. Then I will check this for the subtraction. And then lastly I will check for the division. Okay. So closure property means if I am adding 2 plus 3, this is equal to 5, or 4 plus 2 is equal to 6, or 7 plus 3, this is equal to 10, or say 8 plus 4, that is 12. So see, 2 is the whole number, 3 is the whole number, and the 5 is the whole number. So you can see that all these are whole number, and after operation these also are the whole number. That means the left hand side is the whole number and the right hand side after operation is the whole number. So we can say closure property for addition is true. Okay. So this closure property for addition is a true closure property. Now next come to the multiplication. So I am taking, I need two number. See, I have 2 into 3 is equal to 6, or 4 into 2 is equal to 8, 7 into 3 that is equal to 21, 8 into 4 that is equal to 32. So after operation we are getting the whole number. After addition we are getting the whole number. So that means closure property for multiplication is true. Okay. So it is also true. Now come to the case of the subtraction. In the subtraction, let's suppose I have 5 minus 2 that is equal to 3, 4 minus 3 that is equal to 1, and let's suppose 3 minus 4 that is equal to minus 1, 5 minus 7 that is equal to minus 2. Now come in the subtraction portion. 5 minus 2, you are getting whole number. This also whole number, but this is not a whole number. In your earlier class, you will study about -1, these are called the integers. Okay. So for subtraction, closure property is not true. Now come to the for the division. For division, I have, let's suppose 25 divided by 5. You are getting how much? 5. Likewise, 100 divided by 10, you are getting 10. Now let's suppose 2 divided by 3, so it is your 2 by 3. Similarly, 5 divided by 7, so it is equal to your 5 by 7. So in the case of division, these all are the whole number 5 and 10, while this is 2, the 2 by 3 and 5 by 7 is not a whole number. It is rather it is a rational number. So for the division, closure property is not true. After the closure property, we are coming to the next one. That is what? That is the commutative property. Okay. So come to the next one. That is your commutative property. Next is commutative property. Commutative property. Commutative property. For this commutative property, we again discuss all the 4 cases. All the 4 cases. We will again discuss. All the 4 cases means for the case of addition, then for the case of multiplication, then for the case of subtraction, and lastly for the case of division. Now first of all I will see the addition. See, if I have 2 plus 3 and if I reverse it, so it is your 3 plus 2 which is equal to 5. Now let's suppose I am taking one more. 7 plus 2 plus 7, this is equal to how much? 9. So see, in the case of addition, if I reverse the digit, like 2 plus 3, 5, 3 plus 2 is also 5, 7 plus 2, 9, 2 plus 7 is also 9. So that is commutative property is, this is the true, and it is true for the addition. So for addition it is true. Now come to for the multiplication. In the case of the multiplication, 3 into 2 is equal to 2 into 3, and this is equal to 6. Likewise here also 7 into 2 is equal to 2 into 7, that is equal to 40. So for the multiplication, 3 into 2 is equal to 6 and 2 into 3 is also 6. So I can say that commutative property for the multiplication is also true. Now come to the subtraction. Let's suppose I am taking 5 minus 2 and then I am taking 2 minus 5. So this is not equal. 5 minus 2 is equal to 3, while 2 minus 5 is equal to minus 3. Then I am taking one more example. Let's suppose 7 minus 3 and 3 minus 7. 7 minus 3 is 4, 3 minus 7 is minus 4. So these two are not equal after reversing. So it is commutative property is not true for the subtraction. Now coming for the division. Let's suppose I am taking 4 divided by 2 and 2 divided by 4. It is also not equal. 4 divided by 2 is how much? 2. That is the whole number. While 2 divided by 4 is half. That is not a whole number. I'm taking one more example. Let's suppose 6 divided by 3 and then 3 divided by 6. 4 divided by 2, 6 divided by 3 is 2, that is the whole number. While 3 divided by 6 is half, that is not a whole number, the other is the rational number. So for division, commutative property is not true. Now come to the next property, that is the associative property. Associative property. Associative property. Now next we will see the associative property. And in the associative property, we will discuss again all the cases. All the cases I will discuss in this associative property. For we will see the for addition, then next I will see the multiplication, then subtraction, and lastly for the case of division. So for the associative property, let's suppose I am taking one example, 4 plus 3 plus 2. 4 plus 3 plus 2. Making a bracket here, and now I am taking the bracket here. So you will see here, what is the value here? 3 plus 2, 5, 5 plus 4, 9, 4 plus 3, 7, and 7 plus 2, 9. So it is equal to 9. So for addition, it is equal to 9. I'm taking one more example. Let's suppose 5 plus 6 plus 7. Here also 5 plus 6 plus 7. 6 plus 7 and then 5 plus 6. So for addition, associative property is true or not. So you see here for the left hand side how much? 6 plus 7, 13 plus 5, 18. Here also 6 plus this. Here also 5 plus 6, 11. And 11 plus 7 is equal to 18. Okay. So for addition, associative property is true. Now come to the for the multiplication. Let's suppose 4 into 3 into 2, and here also 4 into 3 into 2. First of all, I will take these two, and then I will take these two. So if you see the here, how much you will getting? 3 to just 6, 6 into 4, 24. 4 into 3, 12, 12 into 2, 24. So these are the equal. Now I am taking another one. I am taking 2 into 3 into 5. 2 into 3 into 5. So I am taking 2 into 3 into 5. I am taking one bracket in this way and then one bracket in this way. So 5 into 3 is 15. 15 into 2, 30. 3 into 2, 6. 6 into 5, 30. So for multiplication, associative property is true. Now come to the case of the subtraction. Let's suppose I am taking numbers 5 minus 3 minus 2, and this is equal to 5 minus 3 minus 2. First of all, I will take these two, and then I will take this. This is last two. Okay, like this. So 5 minus 3 is equal to 2. 2 minus 2 is equal to 0. And here it is 3 minus 2 is 1, 5 minus 1, this is equal to 4. So it is not equal. So for the subtraction, associative property is what? It is not true. Now come to the next one. Next one is the division. For division, let's suppose I have 4 divided by 2, this divided by 1. So here also 4 divided by 2 divided by 1. So I am taking the bracket like this, then this is like this. I am just changing the bracket. So 2 divided by 1 is equal to how much? 2, and 4 divided by 2, that is 2. In this case, how much? 4 divided by 2, that is 2, and 2 divided by 1. Later one take another data here. Instead of 2, let's suppose I am taking 3 here, and here also 3. Okay. So how much it will be? 2 divided by 3, 2 by 3, and 4 divided by 2 by 3. So you will find that this is not also, this is not equal. This is not equal. So for the division, associative property is not true. For the division, it is not true. Now, last I will take the distributive property. Distributive property. Last one is the distributive. Distributive property. This is the last one. Now, this distributive property means what? It is the combination of multiplication as well as addition. So distributive property what? Over distributive property over addition. Over addition. Distributive property over addition. I am taking one example. Let's suppose 7 is here, multiply by 5 plus 4. Distributive property over addition. So this is equal to how much? 7 into 5 plus 7 into 4. After distributing of this addition, so the left hand side, how much you get? 5 plus 4, 9. 9 7 ja 60, 63. And here also 7 plus 5, 7 into 5, 35 plus 28. So 63 is equal to this 63. So this is the distributive property over addition. I am taking one more example. Let's suppose I have 6 into 3 plus 2. So how much it will be? It is your 6 into 3 plus 6 into 2. So 3 plus 2 how much? It is a 5. So 5 into 6 it is your 30. 6 into 3 18 plus 12. So it is 30 and 30. So this is the distributive property. Now we will discuss the identity and patterns. So first of all, I will discuss identity. Identity first of all I will discuss. Identity. I will discuss the identity first. Identity. So in the case of the identity, I will take for the case of the addition. Addition and multiplication. For multiplication. Let's suppose I am taking 0. So 3 plus 0 equal to 0 plus 3 is equal to 3. And 5 plus 0 is equal to 0 plus 5 is equal to 5. So adding 0, I am getting the same values. So that means what? That means 0 is identity. 0 is identity. identity for addition. For addition. Now for the case of the multiplication, 3 into 1 is equal to 1 into 3 is equal to 3. Similarly, I can take 1 into 4 is equal to 4 into 1 is equal to 4. So value is not changes after multiplying it by 1. So I can say that 1 is identity for multiplication. Is identity for multiplication. Now I will come for the next one. That is what? That is the patterns. Patterns. We come to the patterns. So whole number can represent just like a patterns also means dot structure. For example, I am taking for as a line. If 2 is there, I can represent as like this. If 3 is there, I can write it like this. So I can represent this whole number as a patterns like a line. I can represent as a rectangle also. For example, let's suppose I am taking 6. So it can represent as a rectangle also. Then I can represent this as a whole number as a square also in the form of square. For example, let's suppose 4 is there. I can represent this as a square. Then suppose 9 is there. I can represent this also as a square. Then I can represent as a triangle also. Like if I have 3, I can represent like this, which is a triangle. Then let's suppose 6 is there. So I can represent this as a triangle. So this I can represent as a triangle. So these are the patterns. Now patterns like observation, we will see the next one. That is your patterns like observation. Patterns like observations. We'll see the patterns like observation. For example, I have 117 plus 9. This I can write it 107 plus 10 minus 1. I can write in this way. Then next one is your 84 into 9. This I can write it 84 into 10 minus 1. Then the next one is 84 into 9. Another one is, let's suppose, 64 into 5. This I can write it 64 into 10 by 2. Patterns like of observation, this helps in calculation. So I will just 117 plus 10, I will add it and then I subtract minus 1. Similarly, 84 I multiply by 10, then I will subtract 84. In this case, what I will do, I will take the 64 by 2 and then I will take the 10. So in this way the calculation makes easy. Thanks for watching. If you have any doubt, write in the comment box. If you like the content of video, please like it, subscribe it, and share with your friends. Thanks.